So what we're going to do is use our free software to automatically process all of those video files that we captured when we were outside in the observatory looking at Saturn. The first program we're going to use is called AutoStakkert, and what AutoStakkert does, it finds the sharpest frame in the video file, it rejects all the ones that have been blurred, and we can then stack the good ones, or stack the good ones that we want to keep. We're then going to pass that stacked file into Registax, and Registax then uses the linked wavelets, uses these sharpening tools, and that brings out all these fine details, all these sharpened details as well. And then when we've processed each video file, we've rejected the blurry ones, we've stacked the good ones, we've sharpened the stacked good. We're then going to put that into WinJupos, and what WinJupos does is it derotates that planetary rotation, and then we can stack them again. So we get all this beautiful details, all these beautiful data points. And it's all there in the video files, it's all there in the data, but by using the freeware we can then bring out all these features in our photographs. So feel free to use anything I've shown you in this video, feel free to use those for your setup, for your telescope. So I got myself a cup of tea, which is the most important part of your image processing, and what we're going to do now is quickly go through how I turn those sort of blurry, grainy video feeds that we recorded straight off the camera, straight through the telescope, into a nice final image. So before we start doing our image processing, remember we used FireCapture to actually capture the video files. Now I'm using the dummy camera here, this is just set up in the warm room, this isn't my imagery. But so when you're doing your image capture, click on the settings, and I always use universal time. That means you don't have to worry about time changes, wherever you are in the world, it always uses universal time, it doesn't use the computer's local time. And then you also use WinJupos file naming, and we'll come back onto that, why that's important later on. So use universal time and use the WinJupos file naming. So while we're going through our Saturn image files, I thought it'd be useful to let you know we've started a Patreon account. So although these videos, they're free to watch, they certainly aren't cheap to produce in terms of both the time and in terms of the equipment. So if you are able to support Refreshing Views, this will help us to keep the lights on, or rather keep the lights off, at the Refreshing Views Observatory, and it will help us bring you more videos as we explore the night sky. So I'll put a link into the Patreon below, and if you are able to support, it really would be gratefully appreciated, so thank you for your time. So I use AutoStakkert. Let's move you to there. So we'll go File, Open, Video Files. So here are all my video files, and if you remember in one of my last videos I said always use the WinJupos naming convention. Well, now I'm going to show you why. So all the numbers are in there, they're all labelled up, and that's the year, the month, the date, the time, and the fractions of a minute in tenths of a minute. So what I'm going to do is select them all. I'm going to go Open, and then make sure you're selected to a planet. I generally leave the noise robust to normal, just leave it as it is. And I'm going to set myself to, say, 104 alignment points. So place APs in the grid, and I've set the max brightness to 10. So if you have that down at 0, it does all of them. So you get a lot more alignment points than you actually need. You don't need that many alignment points in the black. That's just adding to the computer time. So have it at about 5, maybe 10. There we go. Now coming up here, you've got the number of frames to stack. I generally stack about 1,000 or 2,000. Some people do 10%, 50%. It really depends on your seeing conditions, your telescope, how bright your histogram was. So let's go with my sort of lazy default 1,000 at 2,000 frames. We'll delete these ones out. So you can either do number of frames or percentage. That's 2,000. And I save mine as a TIFF, so I've captured in 8 bits. That's just to help get the data. Sorry if you can hear any of that sort of background noise. There's an aircraft just going past, so hopefully the camera doesn't pick that up. So I capture in 8-bit and then process in 16-bit. So we'll then press stack. Now at this point I normally go away and I'll do another job, because this does take a while, particularly if you're doing lunar images, which of course are massive. If you've got a nice big thing, and you can hear the computer fan suddenly kick in as it crunches all the data. So we'll leave that running. I'll go and do something else, and I will see you back in a second. So AutoStakkert's now stacked. It's gone through each of those video files, whatever, how many thousand frames it was. It's then sorted through them, and then it's found the sharpest frame, and it's then stacked the sharpest frames. It's then rejected all the blurry ones. So we now have 1000 frames. So AutoStakkert's frames 1000. So there we've got all the, so here we have all the stacked frames. That's the best 1000 frames of each of those video files. So they're all on there. And you can see there, as we said before, that's the naming convention that WinJupos uses. So they're all stacked. What we're going to do now then, if I minimize that, is go into a Registax. Now what I'd love for someone to do, and I'll leave this as a challenge for the audience, is I wish there was some program that did this all. You don't have to jump from FireCapture to AutoStakkert to Registax. If there's one program that did this, you know, automatically from that sort of image capture into the processing, sorry, into the sorting, the stacking, and then the sharpening. It's a shame we don't have one program that does that well, that's still supported. But this software is free, so I guess we can't really complain if people are willing to give this stuff to us for free. Right, so we're into Registax. Now Registax we're going to use to sharpen that stack, and it's still, even though it's years old, it's still the best sharpening software out there. So let's go to select. So here we are in a Registax 6. Those are my video files that we captured last night. This is the aircraft goes past again. So let's open up the first one. So there we have it. We have a raw stacked image of Saturn. We've done no sharpening of this yet, but what we've done is by stacking all those images together, all those 1000 frames together, we've also got 1000 signal files stacked on top of the other, and that means your noise will average out. So we can now sharpen this without processing so much noise. So the first thing I do is do my RGB balance, auto balance that, and that gives it a more natural colour look. Now, when I was starting, I used to move these sliders around. I didn't really know what on earth I was doing. So, but I now know from, and I got to give a shout out to Martin Lewis of Sky Inspector. Have a look at his website, amazing stuff, what he does. So he clicks on Use Linked Wavelets, move that all the way up to the top. Come on, you. There we go. Now that looks a bit like sort of a newspaper image. It's got this sort of grey, peppery sort of dots matrix. So we're going to use a little bit of denoise. Let's move that up now, 0.3. That looks a bit softer. What we can do is then use this sharpen here. Let's move that up to 0.2. Oh, that looks a bit grimmer, but a lot sharper. So let's maybe try that up to 0.5. And basically, I move that slider all the way up. I then adjust in my sharpening and denoise to taste, and you'll have to vary this on your camera, on your settings, and however you do it and what looks good to your eye. But I literally am going to play around with that. So I think that looks a bit sort of over processed. The colours there are quite strong, so maybe we move that down just a smidge, and maybe reduce that, I don't know, down to 1.8. And again, it's starting to make that colour look better. So you've got this trade-off, this constant trade-off between the number of frames you want to stack, which obviously reduces the noise. The more frames you stack, the less noise you have. But particularly if you're like me and you don't have the best of seeing, of course that number of good frames falls away very quickly. So if you stack more frames, you reduce your noise, but you've got a lower quality image, you know, it's not as sharp. So it's this constant trade-off, you know, between capturing good frames, getting good, reducing the noise, making sure they're sharp. And there's no right answer, you just got to play around with it and see what works, but definitely use the linked wavelets. Cool, there we go. So I actually have this saved as a default Jupyter linked wavelets. There we go, and that seems to me, just to my eye, just by looking at it on the monitor, that seems to be a nice compromise between getting a sharp image and not over processing it and making sure we've reduced the noise. Now we can do a further trick to further reduce the noise, so I'll do all of those in turn. Right, so what we're going to do then is we're going to do each one in turn. We're going to save image, and I'm going to call it linked wavelets. And we'll see there, I've saved it as a 16-bit TIFF file. Open that up, save it into there. Select the same one. Hit auto balance. And because we've already got the settings set up, it just processes it automatically. Save that into linked wavelets. Just quickly do all of these. Right, so we're going to use our third bit of software now, just as the train goes past. And that's WinJupos. So WinJupos again is another bit of freeware, and what it does is it can look at each planet in turn and then stack, derotate. Now don't forget, particularly when you're looking at Jupiter rotates so fast that you can see that rotation in a few minutes. So what it does is it calculates where those cloud features are, where those storm features are, and actually corrects for that rotation. So pretty advanced maths. We're going to go Program, Celestial Body, Saturn, Recording, Image Measurement, open our image, go into our linked wavelets. Right, we're going to get that white circle. If we go to Adjustments, we're going to get that white circle over Saturn. So page up, page down makes it larger and smaller, and N and P make it rotate. So let's get that round there, and then up and down the arrows. On Jupiter you can just press F11. It's so annoying that it doesn't work for all the planets. You'll do this by eye. Oops, wrong way. So I'm pressing P there to rotate it. I'm going to make it a bit bigger. Let's get that lined up. A bit bigger again, I think. Get that down, a little bit of P. That's not looking too bad. Now I have seen some people who deliberately capture an overstretched image that shows the moons, and then you've got these little white circles. You can then line the moons up perfectly, and then you know you're precisely lined up. You're not using the disk of the planet. But that doesn't look too bad to me. And I'm going to say image, save, and I come up here and I'm going to make a new folder called WinJupos. Open and save, and I'm literally going to do that now with all my images. F2, save it in WinJupos, open image. Now because I'm tracking equatorially, the field of view hasn't rotated. So when I used to have my AZEQ6 tracking out azimuth, of course the planet would slowly rotate. So this is another advantage, I think, of having it in the equatorial mode. So I'm just going to keep on saving all these. Right, let's close you down. We're going to go Tools, Derotation of Images. Let's move you a bit there. And let's go Edit, Add. So what I like to do is just grab them all. So just check those there. So that's on the 9th of September. Those are the ones we've just done. Let's open those all up, and this big long list comes in. So if you remember at the beginning, we told FireCapture to record in WinJupos format. Now this is why. Because if you record just on the ordinary computer time and the computer date, it automatically, WinJupos automatically reads the time and the date. So if you've recorded whatever that is, 8 or 10 files, you don't have to manually type that all in. So it does save a little bit of time just recording in WinJupos format. Cool, right, there we are, and we're told it to do save it in there, and I always like, for some reason, always saves it in there. Let's go to save it into the WinJupos format. No, WinJupos folder. That's the file name. The size is going to be 5. You can adjust that to whatever you want, and it's a PNG north at the top. Let's hit compile the image. So the good thing about that is that we can now go into Photoshop, or you could probably go back to Registax, and you can now process a little bit more and again bring out more hidden details. Let's go into Photoshop and we'll go open. So there it is, and it's the at 0029, so it's the mid-range through of all those times. So we'll open you up, and then what we can do is go filter, sharpen, filter, sharpen, unsharp mask. And again, you can bring out that little bit more detail. Image adjustments, vibrance. We can bring out the colours a little bit more as well. And I do find if I look at my histogram, I'm sometimes quite dark. I'm only up about sort of half, 2/3. Let's go image, adjustments, exposure. Go up a stop. There we go. That looks a bit brighter. Maybe 0.75. That looks a bit better, doesn't it? Filter. What I was going to do is sharpen. Can I do another unsharp mask? No, let's bring it. No, we're not going to do that. Cancel. There we go. Sometimes I like to do this one. It can just do that. It's the dust and scratches. If it thinks it's an old photograph, and old, if you scanned in a slide, doing a 1 pixel radius, keep that the same 1 pixel. That does actually sometimes get rid of a lot of the fine details. Just makes it that little bit smoother. So there we go. That is a whistle stop processing of a Saturn image. So that is how you can quickly process a Saturn image. So Terry commented on the last Saturn video and says, what's the benefit of derotating, say, Jupyter files? Because when you've derotated and you've stacked those files on top of each other, then none of them are actually much sharper than the original files that went in. And that's the key point. If you've got, well, I'll tell you what, I'll talk you through what I did the other night. So I observed Jupyter for about 2 hours 40 minutes, I think it was. Let's have a look. What was our first frame? So our first frame was at 8:20 local time. So again, that's using the WinJupos format. 30th of November 2023. First capture was at 2022, and our last capture was at 2300 universal time. So what's that? 2 hours 40 minutes. And it was brilliant because we had the great red spot transiting across the surface of Jupyter. So I took, goodness knows how many video frames that is. Let's have a look. Control all. So that was 60 separate captures over that 2 hours 40 minutes. And so what I was doing, I was using the auto run feature in FireCapture, and that takes that regular sequence of video captures. So I did the same workflow. I sorted and stacked in AutoStakkert. I then sharpened in Registax, and then I then looked at each file in turn. So let's go and open them up. So here they come. So this was the first video capture. If I remember right, it wasn't particularly sharp. And what I was doing was just going through each one in turn. Oh, that one looks good, 2028. So some are good and some are really sharp. And that's just a random seeing. Some are particularly good, some are right. That's all right, 2040. Let's keep on scrolling forward. That was obviously a good patch of seeing. What's that, 2057? So some are better than others. So what I did is I then put them each, the good ones, into WinJupos. So I wrote them out on a sheet of paper, and if I have a look on here, WinJupos. So I have a look on here from 2123 to 2134. I thought there were some particularly good images. 21, 23, 26, 29, 31 and 34. They were the ones that had particularly good seeing. So I derotated those pictures. And put them into WinJupos, and then came up with this image here. So there we are. We've got the great red spots in the middle of the field of view, but as you look at them, none of them are particularly much sharper than the original video frames that went in. But that's the key point. It's not because they're sharper, it's because we've stacked whatever that was, 5, 6 video frames one on top of the other. So now we have a better signal to noise ratio. So what we can do now is go and put that into either Photoshop or Registax and do some more sharpening. We can now boost that sharpening without boosting the noise now that we've stacked those frames together. So let's open that up in Photoshop, and then we'll go filter, noise, dust and scratches, just make it a bit smoother at the pixel scale, and then I'll go filter, sharpen, unsharp mask. Let's make that 125 times 2, and look at that, we can bring out more detail. Let's give it another go. Filter, sharpen, unsharp mask. There we go, look at this. And that is because we've stacked, because WinJupos has derotated those images. We've stacked them more on top of each other. The more frames you've got, the better signal to noise ratio you've got, which then means you can then sharpen them some more. So choose your best frames you've captured, derotate them in WinJupos, and you can then sharpen them some more. So the derotated and sharpened is better than just the original file. So I hope you found that useful, and I'll end with the video of that 2.5 hour time lapse, and these are the best frames that I then derotated in that capture as well. And again, it was using that same workflow from FireCapture, AutoStakkert, Registax, derotating in WinJupos, and then finishing them up in Photoshop. So I hope you found that useful, and I'll look forward to bringing you more videos as we explore the night sky.